Hey guys, hoping all is well with everyone. So in this video we're going to be continuing the lesson 1.4 on understanding division with fractions. So this is going to be example 1, and example 1 focuses on dividing whole numbers by fractions. So we're going to be looking at a couple of more applications of what we talked about in the last video, with seeing how multiplication and division are like sibling or brother and sister operations. They have a great way of working hand in hand, and they can show the same value or resultant by using their respective operations. So it allows us to kind of have different methods or multiple pathways to solving real-world problems and story problems and just in general arithmetic. So it's a very beneficial thing to have in our toolbox. So speaking of toolboxes, example 1 says Mr. Roberts has a board that is 3 feet long. He plans to cut the board into pieces that are 3/4 of a foot long to build a set of shelves. How many shelves can he make? So what they basically do here is they represent the two ways that we can approach this. One looks like subtraction, the one on the left, but it's actually kind of a method using multiplication, and I'll be kind of explaining it in depth in just a moment. And then the second one uses division. So let's go ahead and kind of look at the first method and then the second one. So one way it says, write 3 as a fraction with a denominator of 4/12. Now, another way to kind of think about that is we can represent any number as a fraction. So what I mean by that is any number is a fraction with a denominator of 1, because any number divided by 1 is that same value, so we're not changing the value by dividing it by 1, but it's very helpful because it allows us to multiply and divide fractions much more easily, so we can see the numbers that are being operated on in the question at hand. So what they want us to do is to represent as an equivalent fraction with a denominator of 4. So what we would do here is, since the 1 had to be multiplied by 4 to get to this denominator, we have to do the same to the numerator. So 3 times 4 is 12. So whenever you're finding an equivalent fraction, you have to use what's known as a common ratio, and that's going to be multiplying the top and the bottom number by the same value, and that'll give you an equivalent fraction. So I don't want to go too in depth with that, but just to show you how they came up with that equivalent fraction of 12/4. So what they're doing here is they're taking 12/4 and they're subtracting off those 3/4 boards to make shelves until you basically run out and get 0. Okay, so here they did 12/4 minus 3/4 is 9/4, 9/4 minus 3/4 is 6/4, 6/4 minus 3/4 is 3/4, and 3/4 minus 3/4 is 0, with no remainder. Now, even though this looks like subtraction, it's kind of multiplication because of that repetition of 3/4. So if we have 4 shelves and we multiply it by 12/4, or I'm sorry, if we take 4 shelves and we multiply it by no, I'm sorry, take that back. If we take the 4 times, there we go, sorry about that. If we take 4 times the quantity, 3/4, we get that 12/4, giving us that 3-foot board. So if I take 4 shelves, and they're each 3/4 of a foot long, I get a total of 3 feet. Okay. Now, with the second method, what they're going to do here is they're going to be using a method that is very similar. Actually, it is very equivalent to the insider look of multiplying by the reciprocal. So I kind of talked about this in the last video a little bit, but what I want to kind of point out first is I want to go ahead and divide these increments into, I want to show you the whole number quantities in black, just so you can see the overlapping of 3/4 as they are not on a whole number interval the whole time. So as you can see, 3/4 plus 3/4 is going to give us 1/2. So I just want you to be able to visually see that, so we can kind of see where the 3-foot board comes to, because 2 of those 3/4 boards is 1.5 feet. So 2 more, or 4 of them, would be 3 feet. Now I want to go ahead and really talk about this multiplying by the reciprocal thing, but before I do, this is a very, very important note here. So it says when the divisor is less than 1, or when the number that is doing the dividing is less than 1, your quotient resultant is going to be greater than the dividend. And the reason for that is because when you're dividing by a number that is less than 1, you're dividing by a decimal. And when we're dividing by a decimal that is between 0 and 1, our resultant is going to be greater than the dividend. Okay? And here is why. So let's go ahead and look at that multiplying by the reciprocal application again. So if we do 3 divided by 3/4, this is equivalent to 3 divided by 0.75. But again, that gets very tedious in the long division with decimals, and it's not the funnest thing in the world to do long division with decimals. It's not too bad, but again, if we can find other ways to make the mathematics of these story and word problems easier, let's take advantage of that opportunity. So this is going to be equal to 3 times the reciprocal of 3/4. So remember, the reciprocal of a fraction is just the flip-flop of the fraction, to where if you were to multiply the two fractions, you would get 1. So if you were to flip-flop this, you would get 4/3, and this would be 12 over 12, which is 1. I'm going to erase that, but I wanted to just show you it. So now this is going to be 3 times 4/3. So we can see the relationship between multiplication and division with fractions, essentially with this whole idea of multiplying by the reciprocal, because it makes multiplying the fractions so much easier. So now we can go ahead and do this out. This will be 3 times 4, which is 12. Remember that any number is just itself over 1 when it's written as a fraction. So this will be 1 times 3. This is going to be 12 over 3, giving us those 4 boards. Okay? So again, this is literally like taking a 3-foot board and sawing off 3/4 boards equally, and we would get 4 of those. Okay? Now, one thing I do want to take the opportunity to discuss with you guys, just as the opportunity is allowing me, I want to talk to you guys a little bit about the number line. Sorry, I should have left all of that there. I want to talk a little bit about the number line, because the number line is an extraordinarily good tool. It's great, especially in situations like these, because it allows us to visually see everything that's going on, especially in story and word problems. We're able to really break down everything and see how the answer comes about, so to speak. But the one thing I want to just forewarn you on is, going forward, as we start to get to bigger numbers and different scales and things like that, I don't want you guys to get too attached to the number line. And the reason for that is because it's almost like a double-edged sword. It has a great benefit, but it starts to kind of diminish over time, because it's going to start to become more and more tedious to put together, to where you may have the ability to just mentally calculate what you're trying to put in a number line. So just keep that in mind. Again, I really have a high respect for the number line. I just want you guys to keep in mind that as we're gonna go forward and we get to larger numbers and larger scales and more detailed scales, it just becomes more where you want to be a little careful of whether or not you use it, because it can be very time consuming. And then when it comes to like standardized tests and everything, you just want to be really, really careful with time. And again, I'm a visual learner, so I think things like being able to draw pictures and things like that are amazing. Just keep in mind that, you know, you don't want to be depending too much on the number line, okay? I don't want to go too much into it, but just to kind of give you guys a heads up. Alright, let's try this try it question. So it says a board is 6 feet long. How many 2/3 foot long pieces can be cut from the board? Use the number line to show your work. Okay, so the first thing I'm going to do is I'm going to start by labeling this number line from 0 to 6. Okay. The next thing I'm going to do is I'm going to break these up into third increments. So the distance between each line, including the whole numbers, is 1/3 apart. Okay? So what I'm going to do now is I'm going to make those boards kind of like how I did with the runners in the relay race with the explore activity. So I'm going to use different colors here to show you, but I think what I'll do is I'll do circles kind of like how they did in this example here. So this is 2/3. This is 2/3. This is 2/3. So if we have 3 2/3, we have 2. Okay. So then we go another 2/3. Then we go another 2/3. Then we go another 2/3. So we have 6 now, and we're at 4. Let's keep going. So we have another 2/3 is 4 3/4, 4 2/3. Go another 2/3. And then we have, last but not least, this last 2/3. Okay, so we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can make, we have 9 2/3 foot long boards that can be cut from this 6 foot long board. Okay, so that's kind of a visual way to look at it. And again, this kind of justifies what I was talking about, how the number line is so beneficial, especially for visual situations like this. But let's go ahead and this is the division way. So let me go ahead and show you how we mathematically would do this using the whole application of the reciprocal. So we have 6 feet, and we're going to divide that by 2/3. Now again, what we want to do here is represent this as a multiplication of the reciprocal. So this is going to be equal to 6 times, 3/2. Okay. Now remember that 6 is just going to be represented with a denominator of 1. So 6 times 3 is going to be equal to 18. And 1 times 2 is 2. 18 divided by 2 is 9. So you can make 9 boards. Okay. Now what I want to do as well is I'm going to go ahead and actually expand this, because I want to show you this first way that you can do this as well. So the first way, what we can do is represent 6 as with a denominator of 3. So the reason we want a denominator of 3 is because they're cut into 2/3 foot long pieces. So we have 6/1. Remember, any whole number is just itself over 1, doesn't change the value. So we have 6/1 is equal to something over 3, so we had to multiply 1 by 3 to get 3, so we have to multiply 6 by 3 as well. That's going to give us 18. So this gives us 18/3. Now what we're going to do is we're going to go ahead and subtract 2/3 off and see how many pieces we can get. So 18/3 minus 2/3 equals 16/3. That's one board. 18/3 minus 2, oops, sorry, 16. 16/3 minus 2/3 equals 14/3. That's the second board. 14/3. This might take a minute. Minus 2/3 is equal to 12/3. 12/3 minus 2/3 is equal to 10/3. So right now we're at 4 boards. 10/3 minus 2/3 equals 8/3. That's number 5. 8/3 minus 2/3 equals 6/3. That's number 6. 6/3 minus 2/3 equals 4/3. 4/3 minus 2/3 equals 2/3. And last but not least, 2/3 minus 2/3 is equal to 0. So here we have 1, 2, 3, 4, 5, 6. Oops, sorry. 1. Sorry guys. So this is 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, we see the 9 pieces that can be made. Okay. Sorry, that one was a little bit more drawn out. But just to show you that there are 2 ways that we can do this. And again, this is kind of like multiplication. So we would take 2/3 times 9, and we would indeed get 6. Okay. And let me actually go ahead and show you that. So we have 2/3 times 9 is equal to 2/3 times 9 over 1, which is going to be 2 times 9 is 18, 3 times 1 is 3, 18 divided by 3 is indeed 6. Why is the number of pieces that can be cut from the board greater than the number of feet in the length of the board? And the reason for this is because we're not going to be cutting them by more than 1 foot pieces. Okay, so the reason that we're cutting more than the number of feet in the board is because we're cutting less than a foot each time. So we're always going to have a little bit left over from the previous foot going into the next cut. So for example, like using the number line here, the reason that the number of pieces is larger than the board is because it took 3 of the 2/3 boards just to get to 2 feet. So the reason that that works and the reason that the number of pieces can be cut is greater is because those pieces that are being cut are less than 1 foot long. Okay? So let me go ahead and type that out. This is because the length of each piece being cut is less than 1 foot, so there is always a portion always a portion of a foot left going into the, let me see, I want to find the best way to word this, as less than 1 foot, so there are going to be more than 6 pieces able to be evenly cut into, cut into the 6-foot board. Okay. So just to kind of put the reasoning behind this, again, the wording can be a little bit difficult, but the reason that the number of pieces we make is greater than the number of feet in the board is because we're not cutting one or more than 1 foot long of a board each time. We're cutting less than that. So as again we can see here, it took 3 of those 2/3 boards just to get to 2. So we can see right there that we already have more pieces than just in the 2 feet that we're looking at. So again, it's because the number of pieces that we're dividing by, or the length of the pieces that we're dividing, are less than 1. Okay, so that's the real kind of nitty-gritty behind it. Okay, alright guys, I hope this helps you out. If you have any questions about this, please let me know, and I'll be more than happy to answer those for you. But I hope this helps you out, and as always guys, please take good care of yourselves, and thank you so much for watching.